Good morning and welcome to GoFormative number 39. Dun, dun, dun. I don't know why, but it is circle day. We're going to do some circles. So maybe we should start off with a quick review of some circles to make sure that you are all refreshed. Okay, so let me get a couple circles here. Will it help me out? Good. Okay, maybe one more. Help me out. Thank you. And let's go with some terminology. Okay. Circles, basically the whole point, the whole math point of doing circles is to figure out the length around a circle, the length across a circle, and sometimes we need to know half that length, which is, the radius. So sometimes we need to know the entire length, the diameter. The part around the perimeter, we don't actually call it the perimeter of circle. We want to say circumference. Circumference, circumference, circumference. So outside of like these three things, like that's it. We just need to know these three things. Once we understand the radius, diameter, circumference, then we can find the area as well. Now the area is a separate equation. Area equals the radius times the radius again times pi. And pi shows up a lot, and just so we're all clear, pi is a Greek symbol in math that we use to represent an irrational number 3.141592, blah, 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 blah. And it goes on forever and doesn't repeat, making it irrational. So we can just use 3.14. If you don't have a pi symbol, you can just use 3.14. And that is all good for this part. So knowing the equations help. Okay, and there's the area. And maybe one other equation, circumference equals the diameter times pi again. So if you don't know radius and you don't know diameter and you don't know how to find those, then you are going to really struggle at how to do these equations, because one of these equations calls to use diameter and one calls to use the radius. So let's make sure we're familiar on those. Okay. Diameter is the distance across. You can see the picture of it. It's a distance across. If I tell you the diameter is 10 inches, then all you have to know about the radius is that it's half that distance. The radius is half the diameter. And what's another way to say that? The diameter is double the radius. It's true. So, diameter is 10 inches. What's the radius? Cut it in half. What's half of 10? 5. Okay, so it'd be 5 inches. That's it. Like, that's it. If I tell you the diameter is 6 inches, then what's half of that this time? 3. And then vice versa. Let's try me giving you the radius. If I tell you the radius is, 20 inches, then what's the diameter? Remember, the diameter is double the length. If I tell you 20, then what's the diameter? 40. So that is it. That's it. If I want the circumference, I just plug in the diameter into the equation. Diameter times 3.14 gets me the distance around, which is pretty cool for any circle that exists in the world. you can take the distance around a circle and divide it by pi, and it will always be this line, the diameter. And you could take any diameter and times it by pi, and it will always be the outside. So they work uh, pretty awesome universal truth. It means nothing like in a math class, but like if you start measuring things at home, you're like, your mind's blown, like, wow, it is real. You go to your lamp and your lamp's a circular base, and you're like, okay, well, I don't have a circular measuring tape. And actually, some of you do. Some of you have a measuring tape that's flexible that you can wrap around a circular lamp. But you can definitely measure the diameter of a lamp in the bottom and with a ruler, and then times that by pi, and that's the distance around that lamp. Um, so something cool. I mean, I don't know. I'm just looking at lamp right now, so that's why. A water bottle with a circular base, you could measure with a ruler the distance across that bottom of the water bottle, and then times it by pi, and that's the outside. There are actual jobs in real world where people are using this. Foresters is one job of many jobs where people use this in real life every day. Now, you might be thinking automatically, well, I'm not going to be a forester, so forget circles. But I actually had a forester friend one time come to my classroom and talk about what he does, and just like he like really showed us how he uses this all the time. So it's not just a forester though. There are many jobs, so that's this is one of those things that actually does get used. A lot of things do get used, but when you're 13 and in school, and school is long, and you feel like, well, nothing gets used, and why am I doing any of this? And that's what you talk in your head, and that's false. Actually, you're going to use a lot of it. Um, there's definitely some you won't use. I promise you that, but you will use a lot. If anything, you're going to use your ability to persevere through math problems, and that perseverance you can use every single day. So I think you have all the basic information. Now let's try some problems. Let's go with some of these. These problems here, what they're doing is they're telling you the radius is this. What's you can just you only need one number. You can find the rest. If you tell me the radius is 9, I can find all the information. So let me show you how that works. So you give me the radius is 9 centimeters. Okay. Automatically I can double that to 18, and now I know the diameter. And because I know both of those, I just need the two equations to help me find the rest. So you take circumference and you take area and you plug in those values. 18 times pi, 9 times 9 times pi. That's it. Just plug it in. Calculator will do the rest for you, and that is perfectly fine. You're going to get a decimal or something. I might have a calculator option right here. Let's see. Clear that. No, I don't want to do that. Okay. 18 times 3.14. So my, you know, circumference is going to be that. And then 9 times 9 times 3.14. My area is going to be that. So 254.34. And I would write that for my answer, 254.34. The area is going to be units squared. So if you said centimeters, it's going to be centimeters squared. That's the only like add-on of like, oh, its area needs to be squared. A lot of kids, when they do the math, they'll know the math, but they won't finish off with the units. I forgot what the other one was. 56 point something. Let's do it again. 56.52. And that one's just going to be the units. I don't need squared on circumference. So I just did a sample problem where they gave me the radius and I did the rest. Let's try one where they give me the diameter. So let's just say this one right here, it says 20 feet, it's a diameter. So diameter is 20 feet. The radius is automatically half of that, okay? So what's half that? 10 feet, okay? So your circumference in your area is going to be diameter times pi, and your area is going to be radius times pi. So plug in those numbers. So what's the diameter? It's 20. So we're going to put 20 here. What's the radius? It's 10. So we're going to put 10 here. And then the calculator will do the rest. 10 times 10 is 100. 100 times pi is 314. And 20 times pi, well, 2 times pi is 6.28. 20 times pi is 62.8. So 62.8. And now units, okay? Feet and feet squared. And that is the most important part. If you are confused how I got those numbers, I just throw them in your calculator. 20 times 3.14 and 10 times 10 times 3.14. You'll get the same numbers. Here's what my experience has taught me. I did a whole unit on circles in February, and everybody was really good at doing, like, you give them the radius, they do the rest. You give them the diameter, they do the rest. They're really good at that. The problem people were having was if you gave them the circumference, they couldn't get back. Or if you gave them the area, they couldn't get back. And so let's just do one of each of those as well. And let's just use a problem we just did. Okay, see this 62.8? The best way to teach you how to do it is just do a problem we just did and then work backwards. So circumference is 62.8 feet. What's the diameter? Well, how did I get this number? I times what? The diameter times pi. So what's the opposite of timesing something by pi? I would just divide it by pi. I'm working backwards, right? So what is 62.28 divided by pi? It's going to be 20. So the diameter is 20. And now the radius, we already know that, cut it in half. As soon as you have the diameter, cut it in half. And now you need that radius to help you do your area. 10 times 10 times pi, which we already did, 314 feet squared, because it's area. So if you need an equation for that, the circumference equals the diameter divided by pi. You want the other equation, circumference equals diameter times pi. Okay, and actually I think I reversed those. Diameter equals circumference divided by pi. So those are your two equations. I'll even give you a third, which is interesting when you get the relationship between pi equals circumference divided by diameter. So there's a third one. So they all work, right? Take your diameter, times it by pi, get the circumference. Oh, you have the circumference, divided by pi, get the diameter. If you ever want to see that this works, take any circle outside circumference, divide it by its straight line, it will always be pi. So they are connected. Now let's do one where they get the area first. And we can just grab any one right here. So let's just do this one, number 8. Area is 660.9 kilometers squared. I need to know what the radius is, the diameter, circumference. How do I get area? Go back to the equation. How do I get area? I take the radius, I times it by itself, and then I times it by pi. So if I'm working backwards, just do the reverse order, okay? So instead of radius times pi, take your area and divide it by pi first, okay? This is where a lot of people check out or get lost, or I don't know what he's doing. So I'll try to be as clear as possible. Here's the equation again. I'm just going to do, you know, r times r is r squared. So what I'm going to do is I'm going to just write r squared. So first thing I'm going to do is divide by pi on both sides so I can show you something. Area divided by pi equals r squared. If I square root r squared, then it's just r. But whatever I do to one side, you have to do to the other. So the square root of the area divided by pi is going to get me my radius. Yeah, it looks confusing, sure. But it does explain how I get radius by itself, by doing the opposite. So first thing we're going to do, divide by pi on both sides, okay? That's the first thing we're going to do, divide by pi. So here we go. We're going to take 660.19 divided by 3.14. 660.19 divided by 3.14. 210.25. Got it. 210.25. 210.25. We're not done because that equals r squared. That's not the radius. Now I have to think of a number that, you know, can divide, you know, what times what is exactly 210.25. But there's a square root button on calculators, and we can square root both of those values so we can find the radius itself. Okay, so square root that. 14.5, exactly. 14.5, the square root. So now watch. This value is going to go right there for my radius. Beautiful, okay? It's beautiful. 14.5, and don't forget the units, kilometers. Now the diameter, go back to what you learned. Isn't the diameter double the radius? So we're just going to times that by 2. And if you still need the calculator on that, you can just times 2. Good. 29 even. All right. 29. 29 units, kilometers. So now that I have the diameter, I can do my circumference. Remember, the circumference is diameter times pi. So you're going to take this number and you're going to times by 3.14 times 3.14. 91.06. 91.06 kilometers, not squared. The only one squared is the one on the area. Okay, we did it. We did the hard stuff. Okay. Now, I'll do it again. I want you to see something. You can do it in one continuous motion. Okay. 660.19. Okay. Divide by pi first. Square root it. Double it. Times by pi. I got all those numbers in one boom, boom, boom. Need to see it again? Got you. Watch. 660.19. I divide it by, this is the area, right? This is for the tough ones, the ones that people don't like. They don't like the area ones. But you're going to divide by pi, 3.14. Now that's not the answer. I need to square root that. So when I square root it, I got that. That's my radius. I'm going to times that by 2. That's my diameter. I'm going to times that back by pi. That's my circumference. And you can replay that if you want, over and over and over. There you go. All right, that's your lesson on the basics. Now we go to some of the shaded regions. So here's your lesson on that part. Circles have 360 degrees in them. That was not too bad for a freehand circle. 360 degrees. If this one over here is asking for, hey, just give me 150 degrees of my circle, and by the way, it's 10 feet or whatever. Just give me 150 degrees. then you need to know the fraction for 150 divided by 360. That's it. That's what you need to do. You're going to find the area like normal, like you already know how to do. But then you're going to times it by that fraction because you only want a piece of it. What piece do you want? You want 150 degrees of the 360 degrees. So you just want a piece of that. So what information have you been given? They gave you this 10. Okay. So 10 radius. Notice how it's just a line. It's not all the way across. It's just half. So that's the radius. So 10 feet. And then we're going to go with doubling that. Remember how to do that? 20 feet. So now I'm ready to do both my equations. The circumference is my diameter times pi, and my area is my radius times pi. And you might be thinking to yourself, well, we already did that problem earlier. We did. You're right. We absolutely did. It's right there. Okay. However, the answers aren't all the same because the area is just now a piece of that. So we know this is 62.8, and that's going to be feet. And we know this is 314 feet squared. However, I need to do 314 times 150 over 360. And that's going to get me that piece of that. So you can just take your calculator and let's do 314 times 150, get that answer, and let's divide that by 360 because now I have my piece, okay? 130.83 continuous. 130.83 continuous. All right, so that's my, and that's got to have units on it, right? Feet squared. That's how you do that. If you ever get a degrees, just put it over 360. Some people do this. They'll take the calculator and they'll do 150 divided by 360 and actually get the decimal. 0.416 continuous. 0.416 continuous. And then they just do this in their calculator, but it will get the same answer. Up to you on that. I don't do that. It seems like an extra step to me, but I just keep it simple. You want 150 degrees? All right, that's 150 divided by 360. So the only thing you have to remember there is how many degrees are in a circle, which I know 360. All right, is there anything else? Anything else? That's it. There's your lesson. There's your lesson. Again, the only hard part is the students have to work backwards part. So if you need to rewatch that, you can rewatch that working backwards part. And that's it. Thanks for